Hey gang, welcome back to Inverted Pursuits Laboratory. I look like I am probably blurry as heck. This is what I get for having a different lens on today. We're going to be doing a lot of close-up work as we work on the EggTimer Quantum Wi-Fi enabled flight computer. So let's jump into the close-up views because it'll look a lot better. Alright, so as we initially dump out our contents, we have some fairly familiar items. A little baggie of solder. Had a lot of these. We're finally on to, I think, our third bag of solder, which like I just opened. Like I got a lot of it still. A baggie of all our little parts and our parts list. Let me make sure I have got open the right assembly. I do. All right, so we're gonna want to go ahead and open these parts and get them out. So there are a lot of very specific parts. In this assembly. We've got resistors, headers, voltage regulators, beeper buzzer things. All right. So I know what my circuit board is, and I know that this is the Bluetooth chip. So we're going to just set the Bluetooth board off to the side. It's a very nice little board. We're going to get it out of our way. And the board, we will check. It does have a pre-soldered pressure sensor on there, so that's a really nice feature to have already soldered on there for us. And that is the top of the board. So we'll define the top of the board as this edge. It's also the way all the text is written, so you can read the text on here. So if we take a look at how that text is quickly written before we set it off to the side. All right, we have a series of Mosfets. I recognize the 3 Mosfets. All right, 3. Or am I miscounting? I got a count of 3 Mosfets. Got my 4-pin right-angled header. I'll set that off to the side. My screw terminal. I've got some 1/8 watt through-hole resistors. Apparently we're not actually using them. We're just going to use them as leads. That'll be interesting. We've got some 10 microfarad 1206 capacitors. They are not marked, but they're the ones in the clear plastic carrier here. So I'll set them off to the side up here. Ooh, that's a small little guy. We've got 102s, 104s, 103s, 223s. Oh my goodness. All right, on resistors, let's do the resistors real quick. I have got 102s. Yes. Those are a thing. I have got 103s right here. Yes, they also can be labeled apparently 1002s. I've got 472s. I have no clue what the difference is. I have got 223s. And I have got 104s as far as resistors go. Then I have got 0.1 microfarad ceramic capacitors in paper here. And I've got my buzzer. Sorry, I should know what the buzzer was from the get-go. We'll get the buzzer out of the way. Very small package. This is apparently this little guy here. Let me grab my tweezers. This little guy is a SI2301 Mosfet. Very small package with 3 leads, so I'm going to define that as that. I'm going to assume that's another voltage regulator. Nope, that's our IC. That is a surface mount IC. Those are also surface mount ICs. That should be another little guy. This is our voltage regulator. Where do we have the... This is our 8-pin EEPROM SoC. It's actually the first piece we're going to start with after reading the instructions. We'll start with that guy. This is our... These two here are our VN5E106S drivers. They're 8-pin SOIC chips as well. Set that to the side. These are our 3 Mosfets. The 3 Mosfets, they said, will be marked VN... Oh, I have no clue what some of this stuff is, I guess. It's very hard to tell. We have one MOSFET marked 139N06L. That's this guy. So these are actually, this is different than these two. And these two are, oh, these are rectifiers. So that's a MOSFET. These are rectifiers. Okay, I didn't know those were rectifiers. I didn't know we had rectifiers. And then this is our 3.3 volt voltage regulator, which, yeah, it is marked 3.3. So I'm going to go ahead and grab our board down, and I know this is the first piece we're going to be starting with. So this guy actually goes right here in this very little space. There is a little dot on the top of... Ooh, I can't get this open. Our circuit board, our IC that we're about to mount, that defines the direction in which it gets mounted. So we'll try to show that off here in a second. So if you can see for me it's the upper right, for you guys it'd be probably lower left. On this side right here next to my finger, there's a little dot on the circuit. That dot corresponds to this square check mark here, which we're going to adjust light here for a moment. Yeah. So it corresponds to this square here, that little guy. And let's see if we can go ahead and get you guys in a little closer to make this kind of easier to see. Not necessarily going to make it easier for me to solder, but it'll make it a little easier to see all over. So we're going to put a bit of solder on this lead here, and then we will give it a go of getting this to stick down. It's a pretty common process. If this is your first time watching one of my videos, we use the same process for all of this mounting. So we get one lead to go with tin. Now we're going to come in and grab the IC, heat that up again. Gently position the IC. Oh boy. Oh, I had it there for a moment too. Okay, it is attached. Whew. It's not attached quite in the way I would like to have it attached, but our only goal at the moment is to go ahead and adhere
all of these pads to their respective pins. Alright, we'll reheat this last one we started on and try and make sure it's very well adhered.
Alright, I'm going to take this off screen for a moment and get a closer look at it. Make sure it's the way I want it to be. Getting these integrated circuits mounted correctly is very important to the overall build process. Okay, so you can take a look and see that that is attached on there very well. Next, we are mounting a 103 resistor located to the lower left, so that's this guy right here. For me, it's lower left. I got to keep some of this oriented somehow, so unfortunately for everyone, you guys are getting some backwards instructions. If I don't keep myself oriented, we'll build this boards all sorts of wrong. So for me, it's the lower left. I have defined this side as the top of the board for me. For you guys, I know it'll end up being the bottom, but not much I can do about that at the moment. So this 103 spot is right here. We'll heat it up real quick, get a bit of solder on it. Grab our 103. Get in there, attach it, get in here this way, and attach it. And that 103 is on. Next, we'll be going after a 0.1 microfarad capacitor. It's in the paper carrier. It goes dead to the left of the IC, so it actually is going right here in these two spots. So I'm actually going to start by soldering this pad before I get it out. All right. I actually just started filming this video and I just heard my printer finish. Too bad, it's gonna have to wait until I get to a point where I need to take a break in this video. Woo! That took so well. Alright, the capacitor is on. Alright. Oh, there's another one. Sorry, my bad. Another one goes right above the baro sensor right here. Go ahead and get some down. So get the next capacitor out real quick. Ooh. That's a little more how I'm used to these going. Partially chaos-like. Alright. Then we heat and mount the opposing. Alright. The next thing we're doing is mounting the FET. That is this little turd. It is tiny little part. Tiny little part. I wish there was a way to say this thing isn't tiny, but it is tiny. So it mounts right here. There's 3 pads. It's kind of hard to mess up which way this thing mounts.
It's literally only one logical way it mounts. But it is not the easiest thing to get a hold of. Is my current problem. Oh goodness, this is ridiculous, mate. Whoo. No, 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 no. Oh, that was bad. It landed on the soldering iron. We're gonna have to rotate this real quick. Let me check if you guys are still on screen. Kinda are, kinda aren't.
Okay.
It's crooked. Like it's crooked.
But I can solder the pins, so
I'll be able to adhere it in place. Granted, it takes a solder well. Alrighty.
so both those took solder just fine. Next, we're mounting 3 of the 472 resistors. All 3 of them go 1, 2, and 3 across, right there. 472 resistors we just mentioned. We got 3 of them we're going to be mounting. They gave us 4. I assume that one's an extra, and we're mounting all of the relevant ones. So I get them out. They of course all flip upside down on me. I am going to be mounting them. If you've watched any of my other videos, I always mount resistors the exact same way as they are done in the instruction booklet, especially with these little guys. So that means that the 4 will start on this side and the 7-2 will go up, and you will see what I mean in just a second. So just like that. So if we take a look at that, you can see the 472 on there is aligned. So go ahead and tin both those pads. Turn it at an angle just to make it easier to work on. Filming in this way is getting kind of interesting. I've done a handful of videos where I'm sitting here soldering. I'm used to doing projects like this while listening to audiobooks. A lot of my projects I do just listening to audiobooks. I don't really talk through them unless when I need to talk. So next we're mounting more drivers. So these tiny little guys here. We're going to start with the left one, and then I'm assuming we'll move to the right one. Haven't gotten that far in the instruction set yet. Just that it goes that way. That's the way they show it in the picture, and that's honestly the only remotest form of the word notch cut out that I can see. So this pad here, it's going on the pad right here, which has got one large output pad on it, and one on each has a large output pad. And so the way we're going to end up doing this, which I find a little weird, is that we're going to heat up the big pad And amazingly, I hit that. And solder the big pad to the pins. And then now we're going to go in and mount the rest of the pins on here. Should be about as easy as it is every other time I mount a pin, which means both easy and not easy. I always will recommend that you as the individual move your workpiece to make it easier for you to work on, which is why you see me spin this stuff all the time. Is because it's all about making the part easier to work on, because you make less mistakes when the part is easier to work on. Alright, so that chip is mounted. Now we're doing the same thing to the other driver. I've got no explanation for why I think it is the way it is, honestly, at this point. Which is nerve-wracking and anxiety-inducing. So alrighty, there's that one. Let's start with the leftmost pad here. Go to the rightmost pad here. Maybe you'll take solder nicely. Yeah, kind of. It's always important to every couple solder joints to also remember to clean your soldering tip. Clean tips are half the time the only reason my joints take so nicely and so quickly. Typically, if I'm having issues, the moment I just say skip it and clean it real quick, come back, and boom, takes like a charm. Amazing how that works. All right. Next thing we were doing is we were mounting one of our 104 resistors. It's literally the one labeled 104. On to the pad right here that is labeled 104. So again, I mount these things the same way they show in the instructions, which is the same way the 472 resistors went on. So I'm going to gently rotate it. And that is so that the text reads actually from bottom to top is how it reads. So from the bottom of the board, you read 104 to the top of the board. There we go. That 104 is now attached. Now we're going to mount the 3.3 volt voltage regulator. That voltage regulator goes right here. Sorry, let's keep this in view. Goes right there. Our 3.3 volt voltage regulator is this guy. So we always start with the large pad on voltage regulators. It's just kind of the rule. The voltage regulator, you start with the largest pad. They're also often the damn hardest pad to heat up. So I'm going to actually swap hands. Getting pretty good at doing these things backwards. It'll be like the third voltage regulator I've done today. So then we come in here and we're going to solder the other pads. Sorry, I'm forgetting to explain what I'm doing. So we then, once we have it held down with one, we solder with the others and we're good to go. My guess is next thing we're going to do are the 102 resistor, and then I'm going to guess a 223 based on the labeling. So 102 goes here and then a 223 goes here.
So I'll get out a 102 resistor real quick. And for mounting these, they're doing it reading left to right for me. Left to right is left over here, right over here. I get that that's backwards for you guys. I may have remembered to flip the video. Editor me may have figured that out. Fortunately, I can make no promises. Yikes. I tapped the voltage regulator. I did not want to do that. Alright. 102 is tacked. Let's finish soldering it. Here on the other side. Clean that again real quick. I'm not really liking how that's holding on there. There we go. The 102 is now mounted. And then guess what? We're doing the 223 next. I don't think it actually matters if you do that or not, but I like to do it. I find it to be a good habit to hold, is to always mount things in a consistent order. And now that that's tacked, we come in on the other side and we soldered it permanently. And we'll do a quick test hold because that one sketched me out for a moment. I'm gonna reflow the opposing side. Alrighty, reflow this side. There we go. The 223s. We're not doing the 103 modules next. I do need to get some parts to finish this off. They want me to use toothpicks. Spacing hack I'm guessing they came up with. Wish we had had it in earlier builds. That would have made things a lot easier to have toothpicks. So we'll tape toothpicks on here, and then we're actually gonna go ahead and flip this over and work on the components that go on the back. So there's a series of more capacitors and resistors that go back here, as well as some surface mounted components. And looks like our Wi-Fi board also goes back here. So we'll get all that soldered on and be good to go. All right, so our next step according to the instructions is to go ahead and masking tape 2 toothpicks, which I've got right here, to our board. So what we did is we've got toothpicks taped to the board. So when we flip it over, we've got a sturdy surface. Wish I'd known this for previous projects. It's a really good idea, and I really like it. Now we are going to solder a 104 resistor in place. The 104 resistor goes right here. All right, so we're gonna solder on a 104 resistor. The 104 resistor solders on right here. We've got a already tinned pad. Sorry, I did that off camera. While I was getting the soldering iron warmed up, it worked as a very nice first test piece. So we'll get that soldered in place. All right, there's the 104. So after the 104, we're actually going to place 2 10 microfarad capacitors. Now these 10 microfarad capacitors are the ones that come in our clear brown and come in clear plastic tape. They'll both mount right here and here, respectively. So I'm going to go ahead and tin both pads. One pad tinned. There's a second pad tinned. All right. Got my cat over here huffing at me.
Oh no. I thought the solder had already hardened. Alright, we're gonna have to do this sideways. Apparently no good at doing this upright. Alright, let's do a quick solder down on the other side. Take it off screen here real quick, guys. Sorry about that. All I did was real quick add a little bit of extra solder just to ensure I got that down. I'm going to turn it sideways to make this easier for me to get to. Alright, we're doing the other one. Alright, our only goal is for it to be on there at the moment. Now we're going to come to the back pad. I'm going to put a decent little blob there. And we're going to go ahead and add a little more to the other side. And we get a much better mound. Alright. The next thing we're going to be looking for are 103 resistors. So we've got one 103 resistor that will mount just above that. So our 103 resistor mounts right here. And I've still got a decent amount of those left. As far as I understand, I'll be mounting 2 more on the other side of the board. Or I guess what would be defined as the underside. I believe that's how they've gone about labeling these. There we go. Oop, did not mean to pick up my rectifiers. We'll deal with that in a second. Get those guys up off the screen. Alright, there's the 103. Now I need a 0.1 microfarad. So that's one of my unmarked brown in paper tape. It's one of the, it's this guy. They do give us extras on a lot of these, so I've got a decent number of them. I should have pretty much one extra of almost everything if I did my counting correctly. So, unless you lost one previously, when you get down to 1, you should be at your number. I gotta remember to wait a second longer than I keep thinking it's gonna be for getting this stuff in here. Alright, let me reflow this one, add a little bit of extra solder, and it pretties it up so quickly. Alrighty. Alrighty, so we're getting on a weird one here. We're going to set this board aside, and we're actually going to be working on the Wi-Fi module. So the Wi-Fi module has a metal shield on top. This little squiggly guy over here is an antenna. But to start, we're actually going to flip this guy over, and we're going to be soldering leads to it, which, boy, does that feel weird to say. So what I want to do, according to the instructions, oh, that's still too big. When they give me instructions and it's still too big. So I'm going to end up making my own. It's supposed to be roughly 1/4 inch by 3 inches long. I made it definitely way longer than it needs to be. But piece of tape, tape it to my work surface, They said that was what we wanted. And then we were given a package of these resistors. So we have 4 resistors, and we're going to take them out of their packaging, and we're actually going to use them only for their leads, not for actual resistors. We're going to end up making basically our own pin headers for this. I imagine it was about the cheapest way that they could come up with to make pin headers. So you stick a resistor in, come over here, and you solder it in place. From there, you will actually take diagonal cutters and cut halfway between the lead and the resistor to leave yourself a little pin lead, and then you do the same thing over again. Sticking it in the next hole down the line. And this time we cut flush with the resistor body. So I'm actually going to flip my cutters over. And we're just going to repeat this whole process down the line, which seems kind of crazy. This is definitely the first time I've ever made my own leads. I'm probably making a handful of mistakes. I know that none of them are straight. Not overly concerned about that at the moment, that nothing's straight. Just working my way down the line. You walked in at a very entertaining time.
Did I?
I am literally having to solder like custom header pins onto a circuit board.
Fun. I envy you.
I don't envy this either. And then we'll cut the last one off here again. And we just take and get rid of that. And then we start all over again with a new resistor.
Have fun, don't shock yourself.
Don't what?
Have fun, don't shock yourself.
That's kind of hard to do.
You find a way knowing your skills.
I am safe. I promise the internet I am as safe as I can be. And we're just going down the line, soldering pin headers. Why do you torture the cat like this?
I was trying to get him to meow for you. He just wants to give kisses now. Oh, do you like my chair? Oh, yeah?
Just wanting to give kisses sounds about right for him.
Sorry, okay. What would you like to do, sir? I'm gonna go back upstairs.
All right. And after 2 resistors, you'll have one side completely pinned up. And now you take the remaining 2 resistors and do the same thing to the other side. My wife is in the background messing with our cat.
He
Trying.
likes my chair. He's gonna vibe with you down here.
He already kind of was, I thought.
But he's now rolly. Here you go.
Is he now roly-poly-oly?
Yes. There you go. You have a cat.
Thanks, love. I always wanted my own cat. Oh, quite the view. My cat is just in a spare office chair floating around the shop and just vibing. Whoop, sorry I bumped the camera there, guys. This is actually gonna end up being a fairly lengthy video. I'm a little surprised by that. Yeah, he's staying, which is well till now.
Well, I got the picture. Okay. You want to go upstairs or you want to hang out there?
Upstairs, upstairs, upstairs.
You want to go on?
Oh, I don't mind if he's down here or not. I was being me.
Give you some cat purr AMSR. Yeah, asthma.
Alrighty. Next one down the line. We're so close.
Yep, so far.
Boy, that's a mood. Considering the difference in cost between pin headers and resistors, this has to be the most efficient and cost-effective way to have done this. I applaud thee for being innovative, EggTimer. Kind of curious how much of this I actually melted to my bench today. All right. And that is now all 4 resistors used to make leads. If we go ahead and remove the tape, you can see we have quite the interesting set of pin headers that we have now custom made. We'll also have an amount sticking off the back side. What we're actually going to do is take our diagonal cutters and come in here on every single one. And trim them down to make them look nice. Now you want to make sure you try and keep track of all these clippings as you go, so they do not become loose pieces of trash or FOD floating around. Alright, so now we're going to take the tape off our board. We could have done this earlier, as far as I understand now. Now that we're done with all the surface mount components, we can take those off. So we just finished putting these leads on our board, our Wi-Fi module, which this Wi-Fi module is how we will communicate. They recommend we trim all these down to the same length. I am not going to do that at the moment because I want the extra length right now, since all of mine are a little wacky. Someone's going to probably tell me that this is actually making my job harder, and part of me would agree. But considering these pins got a wacky job for me at the beginning, I'm going to quickly do this off screen. Alright, I take that back. We're actually going to go ahead and trim all these down. And pretty much unceremoniously just clipping them down and accidentally doing it off screen. Unintended. It goes in this spot on this side of the board. It's the only side that's marked. The other side's not marked. Hopefully these will line up better now. Probably gonna find out they still don't line up great. Oh, actually that went on way easier. Okay, yeah, definitely trim your leads. So one thing we can do is we can actually make this come down really, really close. But what we want to do is leave a little gap. That's probably more of a gap than what they want. They're recommending like a 32nd of an inch. I think I've got a 1/16 of an inch there. But we're going to leave that as it is and then flip the board over and solder all of the pins for the thing. For it. So the pins are this row of pins here and this row of pins here. We'll start on the back side.
So by the definition of the board, this is actually the bottom side of the board that we started soldering on. The side with the Wi-Fi module is the top. So I had that backward earlier in the video when I was calling out what went where. So we're just kind of bum rushing through these. Trying to make sure we have just enough heat to warm up the pad, build our little mound, and then get off. So overheating parts is how you ruin stuff. Alright, and just like that we have all 16 of those pins done, and there's going to be a little bit left over. We want to actually come in and trim all that little excess hanging off. So we'll come in with our diagonals and trim it a little more. Trim it a little more flush with the top of the board. And I'm going to flip it over. I'm doing this so that all the trimmings want to fall down away from all my excess components, enlarge so I don't accidentally short something. I only have minimal ESD protection at the moment while doing this particular board, so trying to make sure nothing can mess this up. Managed to get a good handful of boards done so far with this setup, so we're gonna keep chugging along as we can. So that whole pin set is completely done, and our Wi-Fi module is mounted. So we're mounting our remaining 103 resistors. So flipping it back over, we have a spot here and here for 103 resistors. And we have two more that definitely needed mounted, just based on the number of parts we were given. And there are those guys. So that will complete all of our resistors and capacitors for this build that we needed to mount, which is always a good feeling once we get those done. So we're gonna go ahead and come in. Ooh. Hello there, buddy. All right. Hardest part of this board at this point is now that Wi-Fi module is on the back. It doesn't want to balance very well. All right, there's the first 103. Get in here and tack it down real quick. All right, tacked. Come in here and solder up the other board, or other pad for our last 103. All right. All right, there's the what? Remaining 103 is now mounted. So we can see, whoop, both those are now on there. And our next step should be the buzzer. So on the opposing side of the board, there is a circle marked right here. This is where our buzzer goes. It is polarized. One lead is marked with a plus and is also longer than the other lead. There's also a plus on the board, so that helps us out a lot. So there's a plus mark on this side of the mount, and our buzzer has a shorter lead and a longer lead. The longer lead does not have, or does have a plus mark next to it, so we will put that in the plus mark hole. Woo! And I shot it off. Let's use my fingers instead of the tweezers for that.
So all right, sorry, it took a little bit of doing to get that buzzer in there. It is a super tight fit between this capacitor here and the Bluetooth mount. So you gotta be on top of your stuff for soldering that guy in there. So, or for wiggling that guy in there, I should be more accurate. Okay, sorry. I was concerned there might be a bridging on this right here. Still a little concerned there might be, so we're gonna go very gently on the solder. Okay, perfect. And this guy. All right, next we're going to be mounting a Mosfet. The Mosfet is marked FQU13N06, and it goes in the spot on the board labeled FET. So on the front side, there's this little spot, wow, I burped, labeled FET. And we have exactly one 13N06L guy. So it does go in a specific way. The easiest way to do that, they like to define it as this metal face needs to be away from the Wi-Fi, but it also just lines up with the white. So that's a pretty easy way to remember it. So we'll just flip it over and solder these 3 tabs. We're actually going to solder one and then check for straightness. Okay. Yeah, that ain't square for anything. All right, there we go. Square up nice and good. And yeah, I'm having some issues, so clean my soldering iron tip real quick. There we go. So once we're done with these, it should tell us to clip the leads flush. It does. So it's as simple as coming in here, and we're just gonna do this one at a time. I'm not gonna try and mass cut these. Didn't cut them quite as flush as I would like, but I got that mounted in there. So the next thing we are mounting are our 2 resonators, which are these 2 little guys. They go in the spots here and here. And just like the other ones, or the other one, they mount with their big metal face aligning with the white stripe on your board. So they will look just like that. So we're going to flip it over. I'm going to tack one of each. Sure I get them square, and then we will call it good. Okay, checking square on them, actually pretty close. they're not sitting exactly where I'd like them to sit. So I am going to do a quick reflow on one of these. Both these, sorry, off screen for you all. I need to be able to intently stare them down. So we'll get in here real quick. Sorry, I am just whipping this around a lot. There's a safer side to solder from, and I would like to make sure I stay on the safer soldering side. All right, here we go. Got both resonators soldered on there. We'll go ahead and clip their leads flush as well. Oh, and I forgot to clip the lead for the buzzer flush. Do that as well. So we got both those on there. So next is mounting the pin block, which this is technically an optional step. The pin block goes right here, and you want it so that your big openings are facing out the side of the board. For what I'm doing, I'm going to go ahead and put the pin block on there because I like pin blocks. They make my life a lot easier for mounting, for connecting and disconnecting my primary wiring from this board. I am going to probably permanent mount some sort of switch connector to this thing, since the switch does not have a terminal block mount option that comes in the kit. All right, there's all four of those. We're not going to trim them down at the moment. So the next thing is our 3-pin header. So if you remember, we have a 4-pin header. We do not have a 3-pin header. What we're actually going to do is take this 4-pin header, diagonal cutters, and just like that, we have a 3-pin header and a 1-pin header, which is exactly what we need for this whole thing. We need one of each. So the 3-pin header goes right here. So we're quite literally going to take the short side here that's unbent. They go down inside there. Hope they're not going to stay. They go right in there, right on like that. I'm going to go ahead and tape it on like the instructions recommend. I'll go ahead and use the tape because they were right. I was hoping I could do it like a lot of these other things. If I don't have to tape something down, I will often choose to not. Because tape is not my favorite thing. All right. I'm gonna slide in here real quick. The 3 pins are right here when we flip it over. Forgot to clean the tip. Yeah, clean tip takes solder so much faster. All right. So that's our 3-pin header mounted on there. That is what we'll be using for primary programming of the unit. We also have a 1-pin header. The 1-pin header goes on the opposing side. So we've got this little spot here. It says 3V3 and it's a little hole. So this is basically a 3.3 volt header. I think it's what we use for needing to pull off on a few things when programming some stuff, which doesn't surprise me. We'll use the tape again. I did line it up to get it flush. Thankfully, this is only one item, so life gets pretty easy on soldering. All right. And that should be on there now. Yes, it is.
That is attached.
All right. So as far as my pile of parts is concerned, I'm out of parts
For this. So the next thing is actually connecting your battery pigtail. So we have a battery plus minus right here. Let's make sure that's on screen. Yeah, battery plus minus spot right there. And we want to make sure we set it up to take the right kind of battery. I'm going to be using 2S LiPo, and they're going to have an XT30 is what my plan is to use on them. And I have one already set up with an XT30 on it, a set of wires. I'm going to go ahead and leave them fairly lengthy. I'm probably going to need to go rescue some more parts. So this is my XT30 connector. It's got quite a lot of wire on it, but wire's not always the harder thing to hide as it is the battery's position when you don't leave enough space to hide something. So I'm going to quickly strip 2 little chunks of braided wire. So there is a positive, negative. There's actually, this is not a polarized unit. They make the comment you can plug things in backwards and it'll be fine. I do have everything set up black, red though, and polarized. So we're going to go ahead and stick with the theme. All right, so I got the pigtails in here. Got it going. So we're gonna come in here with the soldering iron, do a quick solder up job. Do our best to transfer heat to where it wants to be, it also needs to be. So that our solder pulls through. All right, there we go. That took the solder all the way on the negative. All right, so we're gonna hit the positive terminal now. Probably gonna take a few seconds to heat itself up. Oh, it's actually taking solder a lot better now. All right, so there we go. We got solder on both terminals. There's a little bit of extra wire hanging out that we don't want, so we're gonna snip it down a little closer. So we can also put a little bit of hot glue over these to ensure that they do not trip or short. All right, so now we're into the point where we're discussing deployment batteries on this thing.
So this thing has the option to take a secondary battery for right here, just a deployment power, or we can short between here for the use of a single battery. Everything I'm doing, I'm going to go ahead and use just a single battery for what I am wanting to do. I may choose to undo this in the future. I'm gonna see if I actually have some pins I can use. All right, so I'm gonna admit I'm about to cheat. So I have an old RRC3 that I ruined. I broke this chip right here. But basically what I wanna do is I wanna leave the ability for my dual power to go in here, because I may wanna use this for staging in the future here. So I unsoldered this dual post, which is a lot bigger than the one they provided, but it's okay. And what we're gonna do is actually solder it straight onto this board, which seems kind of chaotic, but I'm okay with it because I'm a little bit of chaos to solder this straight onto the board. So, all right, there we go. Got that sitting a lot better now on there. So we're gonna go ahead and use a few dabs of solder around these. Oh no. All right, give that a moment. And get those on there. But then we're gonna go one crazy step further. I'm gonna solder a lead to the B positive post, which I didn't think to collect a lead before starting this segment. That's fine. I have some spare wire floating around for just this purpose. So I need, I'm gonna say I need about 2 inches of wire. Got myself a 2-inch piece of wire. I've got a 2-inch piece of wire here that we're gonna use. I'm gonna strip both ends. Quite literally just gonna slide it into that hole. And it's gonna get routed around just to make sure I route it correctly. And then I am just wiring to this guy. All right. So we're gonna trim that very lengthy lead down, just like all the rest. And now we're left with this little jumper that I simply slide into the aux port, and with my little screwdriver, I come in and I tighten it down. And for the time being, where I'm wanting to fly off single battery, that gives me single battery mode, and I can take that out, tape it off, cover it up, and I will be in dual battery mode. And then I've got my main and drogue charges, but that'll give me the chance to be able to do air start more easily. Takes a little more than, I think, what they'll limit in current to start a motor. And if I'm looking to start a decently sized motor in the air, I want to have some leftover power. All right, so if this thing worked, when we plug it in, we should hear a series of beeps. So that was 3 beeps and a long beep. All right, so that means it worked perfectly. So the next thing we can do is pull out our phone and start working on connecting to the Wi-Fi chip. Now on the packaging you got, there should have been a label. I'm going to cover it up for security reasons. It says EggTimer Quantum and has 2 numbers written on it. These are your passcodes for getting in. One is actually going to be the name you're looking for. The other one's the passcode. I'm not showing you mine, so you guys can't hack mine in the field, because that would be terrible. And it's actually one of the things they do mention is for security reasons. Make sure no one else knows it. So when we are now trying to get our board to work, what we're going to end up having to do is rather difficult. So we're going to come in here on phone real quick. First thing I do is I got to go in here to internet. I've got to turn off that, and then I will need to change what Wi-Fi I am connected to. So I'll come into my settings, do Wi-Fi, and we'll have to find this guy. So we'll want to go ahead and plug it in so that we start. So we got 3 beeps and a long, and about 10 seconds after 3 beeps and a long, it will start broadcasting a 2.4 gigahertz that is called Quantum. That guy right there, Quantum. And we want to connect to that. I've already provided it with my ID that was on this bag here. I'm covering it up so you guys can't get it, but then we will come into I'm going through Chrome, and I've already got a web page set up for it to find it. So this web page is the first thing that pops up. Your unit will beep every time you refresh the page. Let me move the mic a little closer to the unit. So when I refresh the page, unit beeps. Pretty straightforward. So on the main page, we have flight status, which says disarmed. We have our validation code, which we would enter right here to arm the unit. Till then, the unit is completely disarmed until we arm it. Which this is not actually as easy to read as I'd hoped it would be. Past that, we have the drogue altitude, or drogue delay, which we can change by clicking the change button. It gives us a drop down for changing what it is, or we can turn it completely off and hit submit and send it back. The unit beeps every time you submit a change. Our main altitude can also be changed here to anything from, I think it's down to 100 feet. Yep. And like fail safe, nose over, so it can be like, hey, I want to deploy main at apogee, and all the way up to, I believe, 3,000 feet. Yeah, 3,000 feet. So for now, I'm going to leave it here at the 500, submit that back. It also shows us our battery voltage at 8.5. Its current altitude, it knows we're at 662 feet, 201.6 meters. Temperature is currently 82.4 degrees. I think that's a little off. And that's 28 degrees C. Then we have settings and flights. In flights, it gives a list of flight data it's recorded, which since this is a brand new unit, there is no data. And then we also have settings. So inside settings, we have so many things we can change. So we can adjust our launch detection altitude, our samples per second, our descent samples per second. The drogue is if it's on an igniter or a servo. Drogue is like pulse length, 2 seconds. Main, whether it's an igniter or a servo, it's pulse length. Fail-safe velocity. So we can say like, hey, we want it to be going at least like 50, I think it's meters per second. And have been flying for 1,000 milliseconds. Then there's also auto arm, which you can turn on and off, which basically gets rid of the arming sequence. Don't want to mess with that. And break wire function, which we can change to like status or break wire. And then what's the name of your file right now? And then you would submit that back. If you make changes, so you'll change the name of your file and submit it. So it tells me to like make up a name and submit it back to there. There are a few other like special pages you can get to that are listed out in the flight manual, or in like the additional documentation. Many of those things are stuff that's only intended to be used if you're doing like air start or So that's the basics of how to use your quantum flight computer. So when you're done using this, you can just close it. If we were to arm it, I'll go ahead and show you what that ends up doing to the unit. So 7376, and it does every couple seconds reset the arming. And basically it locks down things so you can't change it, although it knows that I don't have drogues initiated there, because like it's off. So like let's go ahead real quick, and I'm gonna use a pair of pliers and I'm gonna short the main, which isn't a great idea to do. I can refresh it. Okay, that didn't actually apparently short the main. All right, let's try that again. All right, there we go. I'm just shorting it across the top. So now it shows like main status is on. So we're gonna go 0554, which is the arming code it randomly generated, and still won't arm it since it doesn't see both. But that's not a terrible thing for us right now. That is how to use your quantum flight computer. Whenever you're done in flight, you can just disarm it from the app here whenever you get back in range and connect to the flight computer again. You can also hook up a telemetry module to this via the 3 pins right here, and then be able to stream data down to your base station. So if you've got like seen your massive base station here. So this massive base station, I've got my GPS site here, and this is my audio for telemetry. So I can actually pull telemetry through this, and I'll have an audio board in here that I'll be able to actually speak out the current altitude, velocity, and event data to me. So I'll actually be able to listen to the flight computer in flight as it's going through all of its operations, which I'm going to be maidening this here in a couple weeks. And I'll probably add that footage here at the end, since this video will be coming out after the flight. Alright, so we're going to do a quick test with our EggTimer Quantum. We also have the telemetry module on the back hooked up. I'm going to turn this guy on with my screw switch. Quantums don't require a screw switch, but I am planning to use this on my L3, so I'm doing that hookup real quick. Alright, so that should have, my web page should now be loaded. So if we come in here, let me tell it to go to our web page again, refresh. Oh wait, whoops, I forgot to change my internet source. I'll do that off screen here real quick. So now we're connected to the device. We refresh our phone real quick. I'm on the test page is what I'm using. I forgot. I have to end up turning off my... Alright, so we're on the test page. We heard the unit beep out there. So we're going to select the drogue channel is what we want to test. You can see we've got blue lights saying drogue status on and main status on, battery 8.4 volts. We've got a validation code there. So I'm going to enter the validation code. And then if we hit test, it will blow one of the red charges. I'm not going to hit test real quick. One of these red charges will blow. I'm actually going to set you guys closer to it than I'm going to be. But, alright. Testing drogue in 3, 2, 1. Oh, 10, 9, 8, 7, 6. You know, give me a countdown. 5, 4, 3, 2, 1. Alright, perfect. So now we're gonna select main. I'm gonna just show you guys this here real quick. So the unit's not armed at the moment. I have to enter in the validation code.
It does now show the drogue status as off and the main is still live. As we can see, the far one over here popped and this one's still good. So let's get ready to do that test real quick. All right, so now we've got a countdown, 10 count, 10,
9, 8, 7, 6, 5, 4, 4, 3, 2, 1, main. Perfect.
All right, now if we take a look at this, we can see that both are off because both have been blown. You guys saw this one quite nicely, but we can see both have popped off. I can now also go back to the 192.168.4.1. that is my quantum. All quantums are this way. You heard it beep. So, and the quantum of course shows both charges are armed, flight status are off. Flight status is disarmed. Battery 8.4 volts. So our quantum worked perfectly on ground testing. So I am very excited to try and test fly this in a few days here.
All right, gang. So we have got an EggTimer Quantum hooked up here. These are my air quotes loads. The proper load to use would be a Christmas light. That's really what they recommend. But even most modern Christmas lights don't have a great load here. Since I'm only going to be arming it for a brief moment, I'm not going to be arming it in test mode, I'm okay just using a quick jumper. I have my telemetry module also hooked in here on the back. I did try to use this in a flight quite recently and made the mistake of putting a steel rod next to it, so this didn't actually transmit any data to me. But we're going to go ahead and turn on the quantum real quick. Alright, so that's the quantum going live. So now I'm going to come over onto my phone and real quick try and connect to the quantum's flight computer. So the quantum flight computer has to be armed, and it's armed via a Wi-Fi browser, which I have right here. This is flight summary. Oh boy. Alright, so here is the current status. Drogue charges are off. There we go. So you heard the beep of the altimeter. That means it read the web page being connected. You can see that our shorts are letting us see the thing is on. We get a validation code, and the current status is disarmed. Over here, I've got this bad boy set up. So we'll turn it on. I've got the antenna on here, so turning it on is not a bad thing. Let's see what we got for our values. Should just go to a ghosted 1. Okay, it does. Alright, now we're going to go ahead and arm the altimeter. It's going to start making a lot of noise. Okay, so it does that 3 beep, and then it'll start to chirp, which is going to get very obnoxious. But there we go. So the moment it starts to chirp, we start to get data. So we get some of the data related to altitude, and we can see it's not gone anywhere. And a lot of the screens will actually appear to be empty until we lift off. So the rapid beeping is that everything's connected, and we are getting full signal as we should. But we can connect a speaker to it real quick and take a look at what it reads. Unfortunately, we're going to have to keep listening to that screaming sound, which drives me nuts. Alright, so we're using my computer speakers here real quick, which you can hear. And so we're going to plug in the computer speakers.
Altimeter ready for launch.
There you go. So it just told us the altimeter is ready for launch. So that's all the info we have until liftoff. Basically, till then, we've just got these blank screens. As soon as we were to lift off, it would start spitting out
Ready for launch.
altitude and velocity. But that tells us that our audio board is working inside this box, and kind of gives you a quick idea of how the audio board connects to your LCD and what kind of information it can give you. We'll go ahead and unplug that so it doesn't keep telling us altimeter ready for launch. But we'll go ahead and turn off this box. We're going to come back over here real quick, and I'm going to disarm the Quantum. This is the proper procedure for disarming, is that I actually get a disarm button, and it kind of freaks out when we do this, but now we're back in a disarmed state and we can power off the unit. So we will power off the unit real quick, come back here, we got a screw switch, the unit is now powered off and everything is safe.
Hey gang, thanks for watching. If you're interested in learning more about the quantum flight computer, there is tons of documentation on the EggTimer webpage that you can go and look up and see all of the cool things EggTimer has been doing to get these incredible flight computers out to all of us. If you're interested in helping support the channel, please consider liking and subscribing, and I'll see you all in the next video.